Ready? All right, so even and odd functions require a little bit of algebra when you're doing them, but you can also do it based off of the graph, okay? So if I zoom this out just a little bit so we can see the whole image, if you look over here on the left, I've got an even function. Even functions are essentially symmetric around the y-axis. Now, the one thing you're going to want to write down, I would do like even this example and then this part right here. Okay? You don't necessarily need the equations as much as you need to know what it looks like and how to find it algebraically. Now, odd functions are symmetric about the origin. And that looks a little funky when you actually go through to graph it. And then the last one is neither. It's not even, it's odd. It's not odd. It just fits into its category all by itself. All right, now visually, they're pretty easy to tell, because if you look at the odd function, see how it's got this little loop up? If you take it and rotate it around, it goes the same direction, right? It's just a rotation around the origin. Yes? Okay, cool. Neither's a little finicky. If it doesn't fit in either of these two categories, it's neither. Okay, no matter what. All right? Now, the algebraic method of proving whether or not something is even, odd, or neither. There's really three things we've got to do. All right? So let's actually do an example. F of x equals x cubed minus x squared plus 4x plus 2. All right, so if I'm looking at that one, I've got a couple of different things that I need to check. So for even, you're just comparing the original to f of negative x. All right, and then if you look at odd, you're comparing this same f of negative x with a negative f of x. All right, so let's go page width, and we'll zoom a little bit. Y'all ready to actually plug in a negative x? All right, so don't overcomplicate this when you do it. You are literally just plugging in a negative x right here. So this is going to equal, I don't want you in blue, go back. Good. It'll be a negative x cubed minus negative x squared plus 4 times a negative x plus 2. Now, what happens when a negative is cubed? It stays negative. All right, so this is just a negative x cubed. minus, what is negative x squared? It's just positive, right? So that sign for your negative stays there, but it's going to be a positive x squared. All right? Now I've got a minus 4x plus 2. So is this the same thing as my original function? Nope, so it's not even. To check if it's odd, we're going to take a negative and multiply it by the entire stinking original equation. So just looking at that and having to distribute that negative through, is it going to be the same as the original? No. Problem lies in the fact that all of your signs are going to change. So it is not odd. All right. So final answer for this one is neither. We kind of ready to try another one? All right, so what am I checking again for it to be even? What? Yeah, I'm plugging in a negative x, so f of negative x. All right. Negative x squared plus 10. So what was that negative squared thing again? It becomes positive. So this ends up being negative x squared plus 10. Is that the same thing as this? Yes, so it is even. Do I have to keep going to check and see if it's odd too? Nah, be done. All right. Now the reason you want to check and see if it's even first is because remember, I need to know what f of negative x is, so I can even check to see if it's odd. All right, so why double the work if I can do it, check and see if it's even, and then I've already got half of what I need to check and see if it's odd. All right, one more, you want to try it on your own? I'll go over it with you, I'm not going to leave you guys. All right, let's do f of x equals x cubed plus 4x. All right, so did we get an answer? What was it? You got neither? What did the rest of you get? You got odd? All right, so let's find out. All right, so it's not even. Check odd, negative, times the whole thing, so it's negative. So remember, for it to be odd, you want what you got for even to be the same thing as what you get. Okay? So this one is definitely odd. Yes, when you plug it in, and I just realized I didn't distribute. No. So, if you look back up here, there's this little invisible negative on the f of x. That's why. Alrighty?